Then we're going to make a table of x values and finding the answers of, let's say this is y1 and y2, and finding the answers of y1 and y2. So the only number or the only value that's going to be the same answer for y1 and y2 is going to be the solution that we have for y1, and x will be the solution for x. Okay, so let's see how this is going to work. Let's have as from -4, or let's say -5, -4, -3, -2. Okay, so let's start solving this together. If we wanted to substitute -5 in y1, it's going to be 3/2 times -5, which is going to be -7.5, plus 4, which is going to be -3.5. Let's start substituting it here. It's going to be -½ times -5 minus 4, which is going to be -1/1.5. Do they have the same value here, the same answer? No. So -5 is not a solution for us. Let's go for -4 here. Let's substitute 3/2 times -4, which is -6, plus 4, which is going to be -2. And let's substitute -4 over here. It's going to be ½ times -4, which is 2, minus 4. It's going to find the answer. It's -2. Do they have the same value? Yes. So this is going to be the solution for us, which is -4 and -2. Using the table, you either can use it like you're going to draw the table by yourself and finding the answers by substituting the calculator, or you're going to use your calculator, put the table mode, and you're going to just substitute y1 and y2 using, this is the graphic calculator, I guess. So I guess it's going to be the graphic calculator. I'm not sure on the Casio calculator if it's there or not, but the normal Casio calculator. But either you're going to do it manually or you're going to use the calculator here. So again, -4, it gave me -2 and -2. They have the same answer. So view the table, adjust the x values until you see y1 equals y2. When x equals -4, both y1 and y2 equals -2. So the solution of the system is -4, -2. Now this is the idea of having method 1 using the graph, or having the second method, which is using a table to solve a system. Let's have one more problem. What is the solution of this system? Okay, so using the graph here, first of all, you're going to graph them, to graph each equation alone. Then you're going to look at the point of intersection here. Let's solve it together. So we're going to find the point of intersection here, which is going to be 2, -1. So 2, -1 is the point of intersection. Let's check if this is going to be a solution or not by substituting it into the equation. Let's have the first equation here. X as 2 minus 2. Instead of y, it's going to be -1. Is it equal to 4? 2 times -1 is going to be plus -2, -1 is going to be plus 2. Is it equal to 4? 2 plus 2, 4, which is equal to 4. So the first equation is true. Let's check the second equation. 3 times 2 plus -1, is it equal to 5? 3 times 2, 6, minus 1, is it equal to 5? 6 minus 1, 5, which is equal to 5. And it means that also the second equation is true. So the solution for this system is going to be 2, -1, using the graph method. Let's see the table method. As we said, either you're going to make it on the calculator or you're going to make it manually. But first of all, you're going to change both equations into the slope-intercept form, which is y equals mx plus b. So the first equation here we're having x, we're going to move everything away from y. So x minus 2y equals 4. This is the first equation. Now we're going to move the x over there. Negative 2y equals minus x plus 4. Now y, we're going to divide everything by negative 2, so it's going to be 1 over 2x minus 4 divided by negative 2, which is negative 2. So this is the answer, or this is the slope-intercept form of the first equation. Let's see the second one, which was the second equation, 3x plus y equals 5. Y equals negative 3x plus 5. So you're going now to make a table for x values and for y1, y2. The solution is going to be when y1 equals y2. So let's have negative 3, or let's say negative 1, 0, 1, 2. Okay? So negative 1, if we wanted to substitute over here, it's going to be half times negative 1, which is negative 0.5, minus 2, which is negative 2.5. This is y1, let's say, and this is y2, okay? And if you wanted to substitute it into the second equation, it's going to be negative 3 times negative 1, which is 3 plus 5, which equals 8. Is this a solution? No, because the answer here, y1 is not equal to y2. Let's go for the second one here. Half times 0, which is 0 minus 2, is going to be minus 2. And for y2, all of this is going to be 0, so the answer is going to be 5. So y1 is not equal to y2, so this is not a solution. Let's go for 1. Half times 1, which is half, minus 2, which is minus 1.5. And here negative 3x times 1, which is negative 3, plus 5, which is 2. So this is not a solution because y1 is not equal to y2. Let's check 2. It's going to be half times 2, which is 1, minus 2, it gives me negative 1. And over here, negative 3 times 2, which is negative 6, plus 5, which is negative 1. Now here, y1 equals y2. So this is my solution. Oops, sorry, it's going to be, this is my solution. So the answer, or the solution of this equation, is going to be 2, negative 1. Either you're going to do the table manually or you're going to use the graphic calculator. Let's check our answers. Here, for method 1, they substituted 2, negative 1 into the equation. So the solution is 2, negative 1. That's right. And method 2, they used the table. First of all, they changed the form of the equation here to the slope-intercept form. This is the slope-intercept form. And then they use the calculator here to substitute different values of x and y. I mean x, and they're going to find the answer for y. So the only answer we're having is 2, negative 1. So that's how we're going to use both methods to find the solution of the system. Let's go to the second idea we're having here. Okay, you can classify a system of a linear equation by the number of solutions. So either we're having a consistent system or we're having an inconsistent system. A consistent system has at least one solution. Yani it has one solution or more than one solution. Okay? An inconsistent system has no solutions here. No solutions. Now, a consistent system is either going to be independent or dependent. Dependent when it has only one solution, and dependent when it has more than one solution or has infinitely many solutions. You have to know the difference between the consistent system and its types and the inconsistent system. Now, here is a graphical solution of the linear system. Intersecting lines, there is only one solution, which is the intersection point. Okay? Infinitely many solutions, it means both lines are above each other. Okay, so this means coinciding lines has many solutions, so it's dependent. Parallel lines, they don't intersect and they're not coinciding lines, so it means there's no solutions, because there's no solutions as long as they're going to move, because they're parallel lines. Okay, just put these 3 points in your mind. And now let's start solving some problems. Let's go to the first. What's wrong here? Okay, let's go to the first problem we have here for this idea. Without graphing, does the system have 0, 1, or infinitely many solutions? They're asking for if the system here is independent, dependent, or consistent. Okay, so let's solve it together. Okay, so how we're going to know? We're going to, first of all, we're going to change each equation form into the slope-intercept form, which is y equals mx plus b. So we can compare between the slopes of each equation and the y-intercepts of each equations. Okay? Of each equation, I mean. Okay, so first of all, let's change the first one here. So 4y minus 2x equals 6. We're going to move everything away from y, so it's going to be as 4y equals 2x plus 6 divided, we're going to divide everything by 4, so 2 divided by 4 is going to be half x plus 6 over 4, which is going to be 3 over 2. So this is the first equation we're having. Let's change also the second equation, so it's going to be as 8y equals 4x minus 12. We're going to divide everything by 8, so it's going to be as 4 divided by 8, which is half y minus 12 over 8, which is 3. I mean 12 divided by 8, which is 3 over 2. Yes, it's going to be 3 over 2. Now here we're going to look at the slope of each equation, and we're going to look at the y-intercept of each equation. So here the slope of the equation here, it's going to be m equals half, m1 equals half, and m2 here equals half. So we're having the same slope, that the lines are either parallel or they're above each other. It's the same line, or the lines that are above each other. Okay, so now let's look at the y-intercept. So the y-intercept for the first one, b1, equals 3 over 2, and b2 equals negative 3 over 2, which means that because of the slope, they're equal, the slopes are equal, and the y-intercepts, they're different. It means that the lines are parallel. They have the same slope but different y-intercept, so the line is parallel. And we said when the line is parallel, it's going to be inconsistent, and so on. Inconsistent, it means no solutions because the lines are parallel. Let's check our answer. Here it's going to be, first they changed into the y-intercept form, here and also here. The slope, it's the same, but the y-intercept, it's different. So it means the slopes are equal. The lines are either parallel or they are the same line, because the slopes, they're equal. Since the y-intercepts are not equal, the lines are parallel, so the system has no solution. It means it's inconsistent. Let me just write it here. Oh. So it means it's inconsistent. Okay? Now let's go for the second and the last problem we have on this idea. Without graphing, is the system independent, dependent, or inconsistent? Okay, let's solve it together. First of all, what we're going to do, we're going to change each equation into the y-intercept, the slope-intercept form. So we're going to start with the first one, which is negative. What's wrong? Okay, so here it's going to be, we're going to change this into the y-intercept form. Negative 3x plus y equals 4. We're going to leave everything away from y, so it's going to be as y equals 3x plus 4. So this is the first one. Let's try the second one. X minus 1 over 3 y equals 1. So it's going to be as minus 1 over 3y equals minus x plus 1. We're going to multiply everything by negative 3 because here it's division, so we're going to multiply everything by negative 3. So y equals negative 3 times negative, so it's going to be 3x negative 3 plus or minus 3. So this is the first equation we have, and this is the second equation we have. So we're going now to compare the slopes and the y-intercept. So the slope for y1, for the first slope we have here is 3, and the slope for the second equation we have is also 3. So this means that the line either is going to be parallel or it's going to be the same line. Let's now check the y-intercepts. b1 equals 4 and b2 equals negative 3. So this means that they're different lines, which means that it's a parallel line. When it's a parallel line, it's going to be inconsistent. It means there's no solutions. Let's check our answer. So 3x plus 4, 3x minus 3, the slopes are equal and the y-intercepts are different. The lines are parallel but different. So the system is inconsistent. Okay, so just let me tell you one last thing here. When you have a system and the slopes m1 is not equal to m2, both slopes like m1 and m2, they're not equal, it means it's going to be independent. One solution. Okay? When you're having m1 equals m2 and b1 equals b2, it means they're the same line or both lines above each other. So it means it's going to be dependent, which means more than one solution. When you're having m1 equals m2 but b1 is not equal to b2, it means that the line is parallel. So it means it's going to be inconsistent. It means no solutions. Just put this in your mind when you're looking at the slopes and the y-intercepts. And that's it for today, girls and everyone, and have a nice day.